Yes, teacher.
Yeah.
Yes, teacher.
For chemistry, we have to study the topics elements of group 1 and 2
And
and
analytical.
introduction analytical chemistry, right?
Yes, teacher.
Hmm. Okay. So it means that you need to know about the periodic table also, right? The periodicity. So,
Yes, teacher.
mm, so इस chapter में basically what we will study about mm, mm, इसमें basically what we will see that group 1 and 2, okay,
Okay.
group
Okay.
1 and 2, both of them they belong to S block of periodic table, and hydrogen is the first element. Now hydrogen, it appears at the top of the group 1 of the alkali metals. So it is on the top of alkali metals, but it appears, yeah, it differs from alkali metals. So therefore we study hydrogen separately. See, hydrogen has got the simplest atomic structure and it carries a nuclear charge of +1 and has one extra nuclear electron. And hydrogen has a very little tendency. Hydrogen has a little tendency to lose this electron. However, when this hydrogen to lose electron, however, this hydrogen, when it pairs with other electrons, then it forms it forms covalent bond. Okay, and next is it always exists in diatomic form, H2 form, and we call it as dihydrogen. So, it is 70%. This hydrogen is abundantly available. 70% of the universe is made up of hydrogen. And therefore, we see that this hydrogen's position in periodic table, it is very anomalous. See, you have written, should I rub?
No, teacher. Just one second. Yes, teacher. Done.
See, basically, what do we see? That this hydrogen, it resembles the outer electronic configuration of group 17 elements. Why? See, hydrogen is 1s1, and this is how much? This is, if I say 287, so 2, 8 and 3s2, 3p5. Now here again it has a deficiency of +1. So we say that it has a valency of -1. So when we add this one electron, it will complete its octet. So therefore we see that every atom tries to complete the inert gas configuration. So therefore we see that chemical properties of hydrogen, they are very similar to the alkali, to the halogens. And this hydrogen, it actually does not exist freely. This hydrogen will always combine with other molecules, and here it will form hydronium ion. So always you can say this H plus combines. Okay. See,
Oh,
because why? Because hydrogen has got only proton. So hydrogen, since it has got one proton only, therefore it is placed above one group. Okay.
okay. Okay.
Now, isotopes of hydrogen, there are three isotopes of hydrogen. Isotopes are what? Isotopes are those atoms of same element but having different mass numbers. So, protium, deuterium, and tritium. So they all contain one proton, one neutron, but they have different number of neutrons. These are the isotopes. Got it?
Got it.
And this tritium, it is a radioactive nuclide. And this radioactive nuclide with a half-life of 12.4 years. And this emits beta particles. It emits what? It emits beta particles. So therefore, we see that whenever hydrogen is prepared in the, should I rub?
Yeah, sure. Sure.
So in the preparations, if we are seeing the laboratory preparations, that when zinc is treated with HCl, it gives us ZnCl2 plus H2O. And if we add NZN to NaOH, then we get sodium zincate Na2ZnO2 plus H2. And by industrial method, we do by electrolysis of pure water. See, pure water is poor conductor, therefore a dilute aqueous solution of acid or alkali, it is used to prepare dihydrogen of electrolysis. Okay, so if we take water and if we electrolyze, it will give 2 volumes of hydrogen gas and oxygen gas will be evolved. So this hydrogen gas is obtained at cathode and oxygen gas is obtained at anode. Electrolysis, and then in this we can add either acid or alkali. Okay. Now
Okay.
pure hydrogen gas. This pure hydrogen gas, if we see, that is not, it is more than 99.5% purified. It is obtained by electrolysis of warm solution of barium hydroxide. And in this case, we are using nickel electrode. Done. Then we see that in hydrogen gas, we see that there are three very important reactions which takes place. See, basically in stage one, what do we see? In stage one, there is a reaction of steam. Reaction of steam on hydrocarbon. So I have taken a hydrocarbon, or I can take a coke, plain carbon. In that, water is added and it is heated at 1270 Kelvin in presence of nickel. So when hydrogen is heated, you get carbon monoxide plus H2. And this is called as water gas. Okay. Now this water gas is very important because it is used for the synthesis of CH3OH. Written?
No, teacher, one second.
Hmm.
Yes, written.
Hmm. So this is used for the synthesis of hydrogen gas. So see this CH3OH, it can be synthesized by using water gas. So CO and H2. क्या है? This is water gas, and this water gas is used to synthesize CH3OH. So therefore, it is also called as syngas. So we have gasification of coal. Syngas means it is sinking a number of hydrogen. Gasification. So carbon, when reacts with water, it in presence of 1270 Kelvin, it produces carbon monoxide plus water. Okay, so this is called as gasification of coal to produce syngas. Okay, so here whatever the the scrap is there, sawdust is there, it is all used in place of carbon. Okay. Now second is we see water gas shift reaction. See, basically we take carbon monoxide plus What carbon monoxide is present in the water gas. Now, when it is heated by steam or reacted by steam, then we see iron chromate catalyst is used. And this iron chromate catalyst, this is called water gas shift reaction, because it is producing carbon dioxide and hydrogen gas. And this carbon monoxide, carbon dioxide is removed by scrubbing with sodium arsenide solution. So basically, major 77% of this hydrogen gas is by petrochemical. So we can say nearly 77%. And 18% of it is coming from coal. Okay. And 4% is coming by electrolytic methods. I am giving you all important points, huh? And
Yes, teacher. Could you
1% by other methods. So this gas is colorless, odorless, tasteless. Hmm?
teacher,
And what happens?
could you show the slide before this for some time? I have to write that percentage values. So, yes, teacher. Done.
So basically, the chemical properties we see that dihydrogen gas actually combines with all the reactive metals and it gives sodium hydride. Okay. So in this case, we see that all the reactions of dihydrogen gas takes place at high temperature. Why? Because the hydrogen-hydrogen bond is bond dissociation energy, means the energy which is required to break the bond. Bond dissociation energy is 436 kilojoules per mole. And therefore, we need nickel as a catalyst. Okay. So why nickel is used as a catalyst? And you know, these reactions are very, very, you can say exothermic reactions. Getting? So when water is
Yes.
formed, you need a catalyst. Similarly, this H2, when it reacts with any, you can say, halogens, fluorine, chlorine. Okay. So here, when it reacts with a halogen in dark, in presence of catalyst, when iodine is there, okay, then
Okay.
it forms HCl. And here it is -2, it is at 250, not minus, it is at 250 degrees centigrade. So dihydrogen gas, in this case, it will resemble the alkali metal. Why? Because alkali metals They react with hydrogen to form halide. And this hydrogen has a reducing nature. Dihydrogen, it reduces, it is a reducing agent. Why? Because it reduces oxides and ions of metals. Those are less reactive than iron. Okay. So basically we see that here they should be less reactive. They should be less reactive than iron. Okay. Now, for example, if we say that you have taken CuO plus H2, it will give you copper plus H2. Then Fe3O4 plus H2, it will give Fe plus H2. Then Pd, palladium, 2 plus, when it reacts with hydrogen, it will give Pd plus 2H plus. So, what do we see? That the hydrogenation of unsaturated organic compounds. Hydrogenation means when in, you have written, should I rub?
नीचे का ही है, so I'm writing those formulas.
Hmm.
Yes, teacher, done.
Hmm. And B is hydrogenation of unsaturated organic compounds. So if I take this unsaturated organic compounds and it reacts with hydrogen gas in presence of nickel, it will give us saturated fat. So basically, the uses are, it is used in the production of ammonia. It is used in the formation of vanaspati ghee. How? By catalytic hydrogenation. एक्चुअली पता है ये वाला सिलेबस नीट में नहीं है हाइड्रोजन. By catalytic hydrogen of oils. Then next is liquid hydrogen is used as rocket fuel. इसमें क्या भरते हैं? Rocket fuel. And it is very important. It is also very useful to prepare, you can say, this methanol in bulk quantity, huge quantity. It is used in preparation of methanol. And along with that, it is used in preparation of HCl and metal hydrides. Got it?
Yes, teacher, done.
Now we'll see about the alkali metals and alkaline earth metals. Group 1 elements, you know na, hydrogen,
Yes.
lithium, sodium, potassium, rubidium, cesium, and francium. These are all the group 1 elements. And you have to write down the electronic configuration. Do you have your book? Write down the electronic configuration. Everyone should have in one electron in their outermost shell. So here it will be helium 2s1. Here it will be neon 3s1. Okay, here it will be argon 4s1. Here it will be krypton 5s 5s1. Krypton, xenon will be 6s1. And last for francium, it will be radon 7s1.
Yes, teacher, done.
Okay, now you have to write down the electronic configuration and open your book. You have your book with you.
Yes, I have my book.
तो इसमें इलेक्ट्रॉनिक कॉन्फ़िगरेशंस देखने हैं. बेरिलियम, मैग्नीशियम, कैल्शियम, स्ट्रॉन्शियम, बेरियम, रेडियम. ठीक है, इन सबका इलेक्ट्रॉनिक कॉन्फ़िगरेशन वैसे ही जाएगा. देखो सबसे पहले क्या करना है, आप लिख लो हीलियम, नियॉन, आर्गन, क्रिप्टॉन, है ना,
हाँ.
जेनॉन, रेडॉन, ये सब लिख दिया. इसके बाद में बस ऊपर से नीचे चलते जाओ. 2s2, 3s2, 4s2, 5s2, 6s2, 7s2. ये इलेक्ट्रॉनिक
Oh,
कॉन्फ़िगरेशन हो गया, क्योंकि इलेक्ट्रॉनिक कॉन्फ़िगरेशन पूछेंगी. सो एल्कली मेटल्स कैसे होते हैं, वो सिल्वर वाइट कलर के होते हैं और दे आर सॉफ्ट. लिथियम, सोडियम, पोटेशियम. हाँ, बेसिकली इसके अंदर में जितने भी अल्कली मेटल्स होते हैं ये सब कैसे होते हैं, सिल्वरी वाइट इन कलर, चांदी जैसे होते हैं. और
okay.
सोडियम तो पनीर जैसा होता है, यू कैन कट इट विद नाइफ एंड सॉफ्ट. एंड दे हैव लो डेंसिटी and they all are electropositive elements. And even the alkaline earth metals, they are also silvery white and lustrous. They are soft. Hmm.
Oh,
They
yeah.
are soft, they are electropositive, but they are less electropositive than alkali metals. So you can write down alkaline earth metals are less electropositive than alkali metals. Okay. And then we see the ionization enthalpies. The ionization enthalpies and the electronegativities.
Mm.
It decreases down both the group. And the elements of both these groups, they have high negative values. High negative values of standard reduction potentials.
Yes, Rikita.
Then we see the chemical properties. See, these all elements are very, very reactive. And they are always found in combined state. You won't find them ever separately. Okay, and their reactivity is first because of low ionization enthalpies. They have low ionization enthalpies. And the reactivity of these metal increases with increasing atomic mass and corresponding lowering of ionization enthalpy down the group. Okay.
Okay, okay, just once again.
Uh, Now you can open your book and do the problems 8.2 and 8.3. They are important. Check if you can understand.
Okay, just
8,
once again.
uh,
Yeah, teacher, 8.2 and 8.3, right?
एक सारा कर लो एग्जाम्पल और देख लो कुछ डाउट है क्या। Neil,
Hmm?
give me a second.
Okay.
Yes, have you done?
Yes, teacher.
Now, if we see the next, you can check up the next reaction with the oxygen. It will all form their oxides. And the
Okay.
reaction of sodium and potassium, it is very, very highly exothermic. And these metals, they get fire very easily when they are exposed to oxygen. And therefore, they are kept under kerosene because of their exothermic nature. And this, we have one oxide, that is potassium superoxide. Now this absorbs carbon dioxide and it gives out, wait, this is a superoxide, and this superoxide combines with carbon dioxide. It gives out K2CO3 plus oxygen. And therefore, this KO2 has been used in breathing equipments. This is your MCQ question. Okay. And this is used by mountaineers. It is used in spaces and submarines. And these, we know that any metal oxide, it is which is there now, it is always basic in nature. Why? Because they dissolve in water, forming, and should I rub?
No, teacher. Yes, teacher. Done.
And whenever any metal, it reacts with oxygen, it will give us MgO, MO type oxides. Okay. And here we will see that if it combines with nitrogen, it will give nitride, magnesium nitride, Mg3N2. Okay. So, and
Oh,
further, if you heat these oxides, they will form peroxide. Peroxide means like hydrogen peroxide. So, these metal oxides which are produced, they are protected from air oxidation. How? By the formation of thin film. And when group 1 metals like lithium, when they react with, when these lithium oxides, when they react with water, they form LiOH. Now this LiOH, it is a strong alkali. Okay, it is a very, very strong alkali. So all the metals, when they react, they form hydroxides, and when the non-metals react, they form acids. Therefore, we say the metals are basic oxides. Okay, and when lithium, sodium, potassium, whenever they react with water, they all float in water. Why? Because group 1 elements, they all form hydrogen bubbles when they react with water. So, and we see that this reactivity increases as we go down. As we go down, reactivity increases, and they are highly, highly exothermic. Okay. Similarly, we see that next is group 2 elements. Group 2 elements, first thing is that the beryllium. This beryllium does not react with water, and the magnesium decomposes hot water. It breaks down, it decomposes hot water. And other elements, you can say calcium. Calcium react with water, it forms calcium hydroxide, and hydrogen gas is liquid. Okay, and whenever they react with hydrogens, they form their hydrides. Alkali metal form their hydrides, alkaline earth metals. When react with hydrogen, they will form MH2. Okay. Now, one question is there. This is your very important question, that NaCl is an ionic compound, but LiCl has covalent character. See, when we see that lithium, the ionic size of lithium is very small. And since the size is small, their charge density is high. So, therefore, when the charge density is high, therefore, they can distort the electron cloud around the negatively charged chloride ions. Okay. Since they can distort, therefore LiCl partially becomes positive, negative. So because of its high charge density, they develop a partial covalent character. And this results in partial covalent character of LiCl bond. Okay. And then we see that Na1 plus ion cannot distort the electron cloud of Cl due to the bigger size of sodium ion compared to lithium ion. Okay. And then we see, this is example number 8.6. Do remember, this is an exam question. Then we see the reaction with halogens, that all the alkali metals, they react very vigorously with halogens. Group 2 metals, they combine at high temperature. Now we see most important is the reducing power. How do we understand that any element has reducing power? See, the reducing power is measured in terms of electrode potential. Okay. It means what? That any metal, when combines, it loses ions. Okay.
Yes.
Any metal with gains and electrons. So all the alkali metals, they have high negative values. Okay, so negative values of E naught, negative values of electrode potential, it indicates what? It indicates the strong reducing nature. And lithium is the most powerful and sodium is the least powerful. So therefore we see that in group 2, all the alkaline earth metals, they have high negative value of standard reduction potential. So therefore we see that group 2 is strong reducing agent. Why one is strong reducing agent and why another? So, alkali metal is a strong reducing agent, or you can say their reducing power of alkaline earth metal is less than those of alkali metal.
Okay. Okay.
Now, next, what happens when they react with liquid ammonia? See, all the alkali metals, they are highly soluble in liquid ammonia. And when they dissolve, they give deep blue colored solutions. So what we see that this M, it combines with ammonia, metal ion, and this is what this is, complex ion. And electron NH3 taken thrice. This is what? This is the ions that they form when the liquid ammonia, because the alkali metals, they are soluble in liquid ammonia. Therefore, they form these ions. Now, this is what we call it as ammoniated. Sorry, this, not this. That is ammoniated ion, and this is ammoniated electron. So this ammoniated electron is actually responsible for the deep blue color solution. Why the solution is deep blue color? And these solutions are paramagnetic. Okay.
Oh,
And they liberate what? Hydrogen gas. Or you can say they liberate. Got it? So therefore, these solutions, they continuously liberate and we get written.
oh, yes.
Okay. And we get, in this case, metal amide. So this blue color, when changes to bronze, then solution becomes diamagnetic. Getting?
Yes. Yes.
Okay, so here if we take metal and then we take ammoniated electron, ammoniated metal, ammoniated electron, it gives ammonia, it is liquid, and this gives MnH2. This is bronze and hydrogen gas is liberated. Am is what? Denote solution in ammonia. Now this is very important. Okay.
Okay.
Okay, so chalo, we'll continue rest of this tomorrow and you learn this by heart. This is very important. Okay,
Okay. Okay.
chalo, bye.
Okay. Bye.